Okay, I'm back, and now we are on part 3 of the lab, which is damped harmonic motion. And it says to take your pendulum, so get out your pendulum again, and what I want you to do is to pull the pendulum out a certain distance, let it go, and then you might need to wait 5 minutes. Okay, so as time goes on, what happens to the amplitude of the swings, and explain why. So this is going to be called damped harmonic motion. Now for the part 4 of the lab, which is going to be on forced harmonic motion, this one is best illustrated using your spring. So I'm going to demonstrate it for you here. Okay, now this is the spring, and now you should have calculated what the frequency of this thing was. So when I pulled it down and then I let it go, it vibrated at a certain frequency. So that's going to be called the natural frequency of the spring. So the frequency at which the mass wants to bounce up and down is going to be called the natural frequency of the spring. And you should have calculated that. Now what I wanted you to do is, if you've got the apparatus, you're going to take your hand and move it up and down at that same frequency. So if this spring has a natural frequency of 2 hertz, then I want you to take your hand and move it up and down at 2 hertz. Okay, so let's see what happens. So I'm going to move back a little bit because I don't want something bad to happen to my computer when I do this. But I'm going to start to move my hand up and down at that frequency. Do you notice what's happening to the amplitude? Okay, you should be noticing that the amplitude is getting larger. So if your hand is moving at the same frequency that it naturally wants to go at, then the amplitude is going to get larger and larger. This is going to be called resonance. The spring is going into resonance. And that amplitude would actually get so large that it would eventually pop the spring. It would stretch out the spring so much that it would come flying off, or something really bad would happen. Now you can do the same thing with your pendulum. Okay, the idea is exactly the same as when you've got somebody in a swing. So that, let's pretend that this is the swing, and your somebody is swinging back and forth in the swing. When do you push them? Well, you can't just close your eyes and, push whenever you want. That's not going to work. What do you need to do? You need to time your push so that when they come back in the swing, that's when you're pushing them. So notice that your pushing frequency is matching the natural frequency of the swing. And then when you do that, what happens to that person in the swing? They get higher and higher. So their amplitude gets larger. So resonance works for springs, it works for pendulums, it works for bridges. So that down in Silver Dollar City, if you are walking across that swinging bridge that they have there, if you're bouncing up and down at the same frequency that that bridge naturally goes up and down at, then the amplitude gets larger and larger. So this occurs quite often, this concept of resonance. Okay, now I want you to do the post-lab questions. We're finished with the lab, and then email it to me, and then I will see you next time.